Okay, in this video, I will cover the YTSS Prelim 2022, question 12, the either question. So actually, this is the harder question between the two. So for those of you who pick this question, unless you have practiced or you have tried this question from the O-level paper, if not, it will be a tough one. Anyway, this question really comes from the TYS. If you go to the chapter on either thermal property or temperature, you will see this question. Now, why do I say this question is tough? Is because down here, you will see that the temperature time graph shows you a flat line. And at first glance, you will thought that, oh, it is a flat line in the temperature time graph. So it means that it is state change. But the question actually tells you that we are heating up pure water. And pure water doesn't boil at 60 degrees Celsius. So if you do not notice that this is not the boiling point and that the temperature doesn't change because of some other reason, basically the whole question you will get very, very little mark. So what happened here is that why is there a flat line? You need to remember the basic. And the basic is that temperature will rise if there is a net heat gain. So what happened here is that when the temperature couldn't rise anymore is because the rate of heat gain from the Bunsen burner to the water is actually equals to the rate of heat loss from the water to the surrounding. So if the water gains 10 joules in 1 second, in the same second, the water loses 10 joules to the surrounding. So ultimately, the water doesn't gain any more heat. And as a result, the temperature becomes constant, right? And you can see that this hint, this information is hinted to you through things like this. Right? Why do they put tin paper cup? Right? So anyway, because of that, you will need to know that in the first 10 minutes, the temperature is rising. So because of that, your IKE is going to rise because IKE is related to temperature. And the expansion of water is very little. So we say that your IPE become constant. And when they ask you at the 30th minute, when the temperature is constant, so you would know that your IKE is constant. There is no state change actually. So you need to recognize that this is not the boiling point. And so your IPE is also constant. And that is where most of you got it wrong. So where does the energy supply to the water goes to? Well, it is being lost to the surrounding, right? Then for part B, again, you need to spot that they are asking you for the initial rise of temperature. So initial, we refer to time at 0. So like what you did in AMAth or EMAth, if you have a curve and you want to find the rate of change, which is the gradient at a certain time, you need to draw the tangent first. So down here, this little green line is actually the tangent at time equals to 0. So once you do that, you need to identify this particular point over here, which give you 1.5 comma 30, and then you take this point which is 0 0, and you'll be able to find the gradient, and the gradient basically will give you the initial rise in temperature per minute. Yeah. So once you know the initial rise of temperature per minute, then you can attempt question part C. So for part C, they are asking you the amount of energy supply per minute. So the only formula you can use is Q equals to MC delta theta. The mass here is in gram, but the specific heat capacity is also per gram. So actually, you don't need to change any of the numbers here. So what are you going to sub into your change in temperature? Well, because they are asking you per minute and you have already worked out the rise of temperature per minute, so you can just use this answer and you substitute into this. So down here, you can actually sub in your answer from B, and you can work out what is the final answer. So the final answer here, unit should be joules per minute. Okay. For D, I'm asking you why the temperature doesn't rise even though heat is continuously supplied. You will get 0 once you mention that it is undergoing a state change or that it is boiling. So like I mentioned earlier in the video, there is no state change. You need to point out that as temperature of the water goes higher, what happens is that the rate of heat loss from the water to the surrounding will also go higher, right? So this is your first 1 mark. Then you need to tell me that the temperature remain constant is because that the rate of heat gain is equals to the rate of heat loss. This will be your 2nd mark. So like I said, if you do not know this and if you have not tried the TYS on this question, very likely you will get this wrong. Yeah. Okay, for part E, you are supposed to tell me which is the best container. Actually, when I set this question, there's only one answer. But as I continue to mark your paper, I realized that actually all 4 can be a good answer. So for your part I, as long as you can give me a good reason, I will give you the 1 mark. Now, what kind of reason I'm looking at? So when you explain why the material you choose is good, you need to show me that you have the understanding that your heat capacity relates to the amount of heat, not how fast or slow the heat is gained or lost, right? And because, for example, if you have a high heat capacity, then you need to tell me that it affects your temperature rise or drop. Because heat capacity tells you that if you receive this amount of energy, how much temperature will change. So when you want to explain why this particular specific heat capacity is good, you should relate it to the speed of temperature rise or speed of temperature drop. It is very different when you explain conductivity, because conductivity tells you how fast or quick energy is being transferred. So you should relate your conductivity to the speed of heat gain or lose, compared to in heat capacity where you are relating it to speed of temperature rise or drop. So as long as you can give me a reasonable answer, I will give you the marks, and automatically you will get the 1 mark reward for your part I. Yeah. Again, if you have any doubts, please approach me so that I can highlight to you what went wrong in your answer. That's the most important thing. And that's all. Okay. I hope you find this video useful, and just remember, heat capacity is always about temperature and heat. Conductivity is about heat and time. Okay, so